Action 1, Inspiring Action.
Look up, because you never know what you will see. Hi, my name is Shen Ge, and I'm the host of SG2 on Space, the only weekly space show here in Houston, with Action 1 Media Group support every Thursday night. So, my goal here is to educate the public in terms of space science, space flight, physics, astronomy, etc. You know, all that cool jazz, and occasionally about aliens as well. So STEAM education, science, technology, engineering, arts, since that's part of the creative aspect, and mathematics is very important to me. And I feel like Action 1 Media's goal is aligned with mine. So together, we hope to encourage the knowledge, and especially the passion and interest in outer space in our Houston community. Tune in to SG2 on Space on Thursdays at 8 p.m. U.S. Central Time. Look up, because you never know what you will see.
All right, everybody. This is your host, Shen Ge. Apologies for running a bit late. Had a bit of trouble getting into this building. Who knew security here was so high, you know? Anyways, glad to be here in the studio. Got a key finally to not have to tunnel through some walls or go through a wormhole. You know what? If I had one of those, that would have been very helpful. Would have been here on time. But that all aside, first of all, you know who I am, Shen, S-H-E-N, last name G-E. You're listening to SG2 on Space, episode number 40. Wow, it's been a while. In fact, seems like it's been a whole year since the show started. All right, at least on Action 1 Media Group, which as you can see, I'm in the studio right here. Speaking of Action 1 Media, their 1-year anniversary is coming up, and Saturday, if you go check out their website, you can buy a ticket. It's weareA1.com, so just go there. If you have some time Saturday night, check it out. There's going to be a nice celebration. So, I was also going to say, actually, I might as well do this shameless promo as well. So there apparently is a Apollo 13 very interesting escape room in the city. And it's the only one that I know that has a space experience called Escape Hunt Experience Houston. And it's called Houston, We've Had a Problem. So it's apparently patterned, and this is only for folks who are in Houston or planning to visit, okay? Who's obviously into space. So it's patterned after the Apollo 13 lunar mission that has been called a quote-unquote successful failure, right? So you and your team will be working under pressure to help your astronauts return home safely from space by solving critical problems like power and life support. People throughout the world watch and wait. You have 60 minutes to save the crew. And 3 of them, up to 3, are going to be astronauts. And then you got to suit up and stuff. So it's pretty darn cool. I actually happen to be going there this Saturday night at 9:30 p.m. So I'm actually going to post that link on my page. So if you guys, and if you want to join me, please just click on the link. And you do have to pay $40, but hey, nothing cool is free. Well, that's not true, but in this case, it's not true, all right? In this case, you got to pay. They're a business. So, all right, so that aside, let's talk about another special topic, which is something that you guys paying attention to NASA and SpaceX and so forth may have noticed. So NASA has announced on July 30th, 2019, obviously, that 13 companies have been selected as part of the Space Act agreement through the agency's Space Technology Mission Directorate to basically develop technologies. So NASA's going to award them money to develop technologies to go back to the moon. All right. So actually, let me clarify. Some of these companies already have money from various contracts with NASA. This particular agreement is not direct funding, but rather allows them to use NASA technologies, right? As well as, possibly use their facilities, NASA facilities, and also tap into NASA, NASA people, the experts that have the knowledge. So, yeah. So, for instance, two companies that comes to mind are Blue Origin and SpaceX, right? The big players. So, Blue Origin, as you may have seen a number of episodes back, showing Jeff Bezos unveiling the Blue Moon lunar lander in May 2019, has won 3 agreements that will work on the lander, and one agreement is going to involve JSC, Johnson Space Center here in Houston. Another is Goddard Space Flight Center, and it's going to cover development of guidance and navigation systems for the lander to enable precise landings. Okay, very important. Otherwise, you'll crash. Second, with Johnson and with JSC here again, and Glenn Research Center, it supports development of a fuel cell for the lander. All right. And then third agreement, this is still Blue Origin, all right, with the Marshall Space Flight Center and Langley Research Center, they're gonna work together on high temperature materials for engine nozzles for use on lunar landers. All pretty cool, right? So, yeah, it's cool that they're able to do that and work with these various NASA centers. Now, for SpaceX, NASA has awarded SpaceX 2 agreements. One is with Kennedy Space Center, KSC in Florida. And this will SpaceX is teaming up with NASA KSC to develop technology for landing large vehicles, like the company's Starship vehicle under development, to land on the moon, right? So how the vehicle's engine plumes is going to interact with the surface. The other agreement between SpaceX and NASA is with NASA Glenn and once again Marshall, and will study in-space propellant transfer, which is pretty cool. So SpaceX plans to use in-space propellant transfer to fuel its Starship spacecraft once in orbit. So imagine that. You, instead of carrying all your fuel to whatever your final destination is, say the moon, instead, okay, I really need to get an Earth or something. That'd be nice. Remind yourself, get a squishy Earth. Anyways, so imagine, say you go up, right? So Earth, you go up here. You only need enough fuel to get into Earth orbit, say, and then you dock, say, with another transferred, basically like I would suppose some kind of orbital gas station of a sort that SpaceX will have, or some other vehicle. And then you transfer the fuel, and then you can go to the moon or Mars instead of carrying everything all at once and going there, right? Since Earth has a huge gravity well, and the less mass you need to launch up, the better. So that's pretty cool. So aside from that, there's also a number of other Space Act agreements, so for instance, there's Sierra Nevada Corporation, SNC. So they have an agreement with Langley, NASA Langley, to develop, say, the infrared imaging of the company's Dream Chaser spacecraft as it re-enters in order to monitor the vehicle's performance. Dream Chaser is a horizontal takeoff vehicle, which kind of looks like a smaller version of the space shuttle. It's perfect. It's reusable. Flies. Well, it still flies directly up. It can land horizontally. All right. So maybe I should change that. It's still vertical, but when it lands, it could land horizontally like the space shuttle. All right. So, and then they have another one with Langley to study the development of a deployable decelerator that could be used for the recovery of like launch vehicle upper stages. All right. I could go on, but point is, there's a lot of these agreements in place. So NASA is really trying to work with these private space companies, which is great because NASA is good at some things, and the private industry is good at some things, right? So it's a synergistic effort. So hopefully everybody's can be able to do this, and we will further develop our private spaceflight capabilities as well as get, say, NASA back to the moon. So with that, let's take a quick break. When we get back, I want to talk about the gist of today's episode, which happens to be on exoplanets after seeing some rather interesting discoveries this week regarding planets outside of our solar system. So let's take a break. We'll be back.
Some of the other things you got going on.
Absolutely. So thank you for having me. I feel like I'm in the presence of like celebrities. Y'all real fans to me.
It's just the shades, man. It's the shades.
So I think like 2000.
Put your money where your community is. Get in the action. Action 1. Independent thinkers working together. Inspiring action in media. Get in the action. Inspire today. Join us by being a sponsor at weareA1.com.
Growing up as a black kid in New Jersey, all I ever wanted to do was be a pro athlete. All of my role models were black athletes. And every time I would stare out the window and look at the sky and wonder what I'd be in the future, it always had to do with me catching some crazy football and scoring a touchdown. When it came to the point that I was told that I would not be able to play on an organized sports team for the rest of my life, it was something that I really didn't even know how to stomach in the moment. And I remember walking out of my cardiologist's office and just sitting in the hallway and breaking down for a few minutes just because it was something that I just couldn't plan for and couldn't account for. And I realized that in that moment, my entire life was going to be changed. And all of those dreams and hopes and aspirations that I had were going to go out of the window.
Action 1. Inspiring action.
Look up, because you never know what you will see. Hi, my name is Shen Ge, and I'm the host of SG2 on Space, the only weekly space show here in Houston, with Action 1 Media Group support every Thursday night. So, my goal here is to educate the public in terms of space science, space flight, physics, astronomy, etc. All that cool jazz, and occasionally about aliens as well.
All right, and we're back. You're listening to SG2 on Space, episode number 40. All right, here with Action 1 Media. Hopefully you're watching us on the YouTube channel. I don't remember exactly, but if you look up SG2 on Space, you're either looking at that or you're on weareA1.com, or, of course, follow me, facebook.com/The Shen Show. All right, so exoplanet focus, right? Haven't talked about exoplanets in a while, which may be surprising. It's just been talking about the moon, right? But really, what's more interesting, to me at least, just beyond the moon, if we think about the future, is going to a different solar system. And what do we do there? Well, besides the science stuff, you want to settle, right? Or some people use the word colonize. I don't like to use the word colonize as much because that implies there's already people there, or things like that. But point is, before we go places, we got to figure out where these things are, right? So lately, there's been some interesting discoveries. So for instance, this week, Hubble telescope have seen a very strange football-shaped alien planet that is apparently leaking metals from its upper atmosphere. Now, I'm not sure this planet is a good one to actually settle, but it certainly has some very interesting characteristics. All right. So just imagine heavy metals, like iron and stuff like that, vaporizing from a surface. Pretty wild, right? Well, that's what's happening. So this planet called WASP WASP -121b. It's what's known as a hot Jupiter. Hot Jupiter are planets that are Jupiter size or larger, but orbits at a distance that's to their sun, to their star, that's less than the distance to, like, from Mercury to our sun. So very large gas planets, typically orbiting very close to a star. All right, that's what, and just what hot Jupiters are. So its temperature is 10 times greater than that of any other known planet. It looks like a football shape because, when I say football, I mean American football, obviously. It's due to the planet's close proximity to the host star. So it's on the verge of being ripped apart, literally, by the star's gravity. All right. So the Hubble Space Telescope can, obviously observe these things. So scientists looked at heavy metals, such as, like I said, iron and magnesium, escaping through the surface of the exoplanet. And this was the first time heavy metals were observed floating away, all right, from the upper atmosphere. So we have, I think, a little video that will show this, which will be up there in a little bit. So just a note, the temperature reaches 4,600 degrees Fahrenheit. That's ridiculous. 2,538 degrees Celsius. All right. And that's the upper atmosphere. That's like crazy. And the planet is not very dense, so all these metals are just like... Okay, sound effects. All right, stop. All right, point is... anyways, so we are going to see more of this once NASA's James Webb Space Telescope goes up, and that's going to launch in March 2021. Let's see, when's that? Still about a year and a half off. But, that will give us more details, and we can see if there's water and carbon dioxide. And, we shall see. Let's see if we can see it.
Headed straight into the blue sky. Its lights wide clean, heading off into infinity. Sometimes that's the way the morning is, and I'm going to give you the morning light bicycle. Put the headphones on, close your eyes, and let the music take where that's not shocking. This is just you listen to the next song. I usually like the way they were all kind of magnified.
All right, guys. So apologies for the lack of sound. Hopefully those online could have seen it. In any case, moving on here. There's something else that's interesting that's discovered by a telescope that's specifically for the purpose of discovering exoplanets. I may have mentioned this before, but the NASA's Transiting Exoplanet Survey Satellite, or TESS, has discovered a number of planets so far. So one of them this week as well, scientists at Dartmouth College in New Hampshire observed this exoplanet named DS Tuck Abe. I don't know if that's how you say it, but DS, like spelled like that, TUC, and then AB. All right, so this exoplanet was found in a two-star system. In other words, it has two suns. Just an interesting fact. Most of the star systems in our galaxy actually is actually binary stars. So to have just a single star like our sun is relatively rare. All right, just an interesting fact. All right, so it was found in a 2-star system, 2 suns, but only orbits one of the stars. All right, it makes one orbit every 8 days, 8 Earth days. So that's super fast. All right. Interesting thing about this star system is that it's very young. It's only 45 million years old, which in cosmic terms is like a baby. By comparison, our solar system is around 4.5 billion years old, right? Compared to 45 million years old. Huge difference, right? So since it's still in the formative stages of its stellar system, the exoplanet is undergoing a lot of rapid changes, such as losing atmospheric gas due to radiation that its host star is emitting, right? So one of the interesting thing about observing this is that literally, if the star system is similar enough to our solar system, then it's like looking into our own past, right? When we look at such a young star system. So what scientists are trying to do is by looking at this particular exoplanet's evaporating atmosphere, we can hopefully predict we can hopefully predict how the world will evolve over a couple billion years. And then we can better understand how these atmospheric losses in the early stage of a star system formation has affected these planets, such as Earth, like where, we lost atmosphere in the beginning as well, and here we are today. So how did that come out to be, right? There's been thousands of exoplanets discovered in recent years, before due to Kepler and now due to TESS. But very few of them actually are young star systems. So this is these are of great interest to us. So, like I said, it's looking back into the past, right? We can see how these planets form. This is also interesting in that, like I said, there's some similarity. So this particular planet that takes 8 Earth days, say, to orbit one of the stars, it's about 6 times the size of the Earth in diameter, which is approximately the size between Neptune and Saturn. All right, so it has a similar composition to, say, some of the outer gas planets. And in any case, in the future, what we're going to try to do, the researchers hope to measure this exoplanet's mass and determine, the type of molecules that are in the atmosphere. So that should be interesting. All right. In any case, just a note once again, how TESS got its name is due to the transit method, where starlight is dimmed when a planet goes in front of it, dimming it a little bit, right? It's just like you have a flashlight, my finger or something, you stand in front of it, it dims the light, right? So similarly, a planet stands in front of the sun, dims the light. And we observe that difference in how much light there are. So, all right. This is all cool, but what about, it turns out there's other stuff you could do to figure out things besides just observational science, right? Theoretical physics, so to speak, models could also help in figuring out, how these exoplanets evolve and, what they're going to do. So, for instance, there's this mathematician. Actually, I will call him. He's a theoretical physicist. Tomasz Kovacs at the Hungarian Academy of Science in Budapest. He has developed a new method for analyzing exoplanet systems. So, in this, he used a method to okay, so let me clarify why this is needed. All right. Even though we have these telescopes and observational data, it is still very hard for scientists to actually predict how these planets will move. So for instance, a previous star, we said, okay, only orbits one of the suns, right? I don't know if that's exactly true. That's what we observed so far, right? But for some planets, it's kind of hard to figure out, how many, like especially like 2 stars, 3 stars. I don't think there are 4 stars, but anyway, like how is it orbiting? Is it stable? Where does it go, right? So this guy, this physicist, Tomas Kovacs, he developed a method to determine whether a system of exoplanets would behave chaotically, meaning their movement changes a lot and might even appear to be random, or regularly, meaning their movement repeats regularly and can be predicted. In our solar system, it's not chaotic, it's regular, right? So this is really important because this movement can actually affect the planet's atmosphere and conditions, right? So it could tell scientists more not only about the exoplanet system, but whether they might be able to support life. So, for instance, if it's chaotic or irregular, it's maybe less likely to be habitable, all right? So this is interesting because his analysis, his method, only uses observed data. So you don't know the equations of the motion of the system, right? You don't have to know the exact gravities of each of the other planets or the stars, right? So you only have the time series. In other words, what you measure from the telescope, their positions. So, which is really kind of interesting. So through observations, you can get ways to determine the dynamics and movements. That's pretty cool math, I think. So Kovacs went to apply his method to the two-planet exoplanetary system called Kepler 36b and Kepler 36c, which orbits the star Kepler 36. As you can recall, Kepler was the first space telescope which discovered a bunch of exoplanets. All right. So the system is actually really interesting because it exhibits both chaotic and regular dynamics. So in any case, it was a easy system to deal with because there were only 2 exoplanets observed, right? So Kovacs said he's going to continue to look at other cases that are more complicated, and let's see what happens, right? So, in any case, yep. And as all science papers go, at least this one actually has a reasonable name. It's called Recurrence Network Analysis of Exoplanetary Observables. Warning, whenever you read these science papers, they are way more complicated than how I present them. So unless you really like math and physics, you don't need to read them. So, okay. Speaking of math and physics, there's apparently some really interesting physics with some of these exoplanets. This week also, it's discovered that magnetic fields of some of these hot Jupiters, remember what I just said earlier, hot Jupiters are Jupiter or bigger size. Jupiter's the largest planet in our solar system, right? So massive gas giants that are orbiting very close to their star, all right? So apparently these hot Jupiters could have magnetic fields that are, 100 times more than our Jupiter, or definitely but of Earth, okay? So these team of scientists, they looked at 4 different hot Jupiter exoplanets, and their magnetic fields ranged between 20 and 120 Gauss, okay? And Gauss is a measurement of magnetic fields passing through the surface, right? By comparison, Earth's measure of the magnetic field is 0.5 Gauss, all right? So that's tiny compared to that. And the measurement for Jupiter's is 4.3 Gauss, all right? So these things, the most massive magnetic field of these 4 is still 30 times that of Jupiter's, all right? This is actually the first time that magnetic field strength has been estimated based on these observations. So we did not know this before. Like, what are magnetic fields? We had no idea. Now we know. So how did these scientists find out? Well, this team, which is led Arizona State University School of Earth and Space Exploration, what they looked at is the star's calcium emissions from the interactions between the planets and the stars. They then combined the calculations of the star's calcium emissions with a theoretical model of how the planet's magnetic fields interact with the magnetic fields of their stars. So, these magnetic fields, right, the planets and the stars, they would interact with each other, twist and stretch the star's magnetic field, so to say, which would cause the ionized calcium emissions to increase for a planet. And so you could figure out, you can model, okay, based on this data, this much calcium was like lost, right? Was lost. Now, based on my theoretical model, this correlates to this much magnetic field for the planet, since I know this much magnetic field is for the star. So you fit your model with actual data, and then you predict, okay, what the actual magnetic field, likely magnetic field of the planet is. Pretty cool. So before we knew nothing. Now we do. So this is pretty big news. All right. And this study is published in the journal Nature Astronomy on July 22nd. So you can look it up. Just look up magnetic fields, hot Jupiters. You'll find it. I'll put it up later as well. All right. So I'm wondering if it's time for a break. But if it's not, I'd like to talk about some planets that may be habitable. So let's go on and talk about that, because I feel like that's the most interesting exoplanets. I mean, we can talk about hot Jupiters all day. They're cool, but they're very unlikely to support life, right? At least life as we know it. So what we want to look at are Earth, or what's known as super Earth. So super Earth are rocky planets that's several times the size of Earth, okay? So international group of astronomers this week as well has discovered a planet using, once again, TESS, NASA's Transiting Exoplanet Survey satellite. And they looked at a constellation Hydra about 31 light years away, right? So the 31 light years is actually pretty close to Earth. I mean, most stars are way further, all right? And remember, 1 light year is the distance light travels in a year, which is about 6 trillion miles or 10 trillion kilometers. That sounds like a lot, but considering our nearest star system is, 4 light years away? This is actually really not that far. But anyways, this exoplanet called GJ357d is only twice the size of Earth. And it's 6 times the Earth mass. It's located in the outer edge of the star's habitable zone. All right. So just give you a quick background. Our solar system, the only planet that we know of that for sure harbors life is Earth, right? So Mars and Venus, Venus, they say, it may have had life before or whatever, but greenhouse effect, right, was too close to the sun, and hence too much solar radiation, and so now it's a hellhole of hotness. All right, Klaus. Mars too far away, too frigid, right? Used to have water and all that for sure, but lost all its atmosphere. So there is a zone somewhere in the middle, and Earth is in the middle of it, where it's a perfect distance away, where you're not going to get burnt up, get too hot, and you're not going to have your atmosphere drift away. All right, so, and get to freeze. So and this is true for every star system. We've determined, okay, there's certain temperature range, and you have to be this far away. There's a band around any particular star where we say this is a habitable zone. Okay, so this planet, GJ357d, is believed to be in that zone. All right. Now, if the planet has an atmosphere, has a dense atmosphere, it could trap enough heat to warm the planet and allow liquid water on its surface. This is according to Diana Kosakowski, a researcher in Germany, particularly at the Max Planck Institute for Astronomy, okay, Heidelberg, Germany. So this potentially habitable planet and 2 neighboring worlds were found orbiting around this dwarf star. And this dwarf star is really a dwarf. It's only a third of the size and mass of our own sun, and 40% cooler. So 40% less bright, right? So TESS noticed that this light coming from this really tiny star dims every 3.9 days, right? So hence we found the exoplanet. All right. Now, note that GJ357b is is way closer to the star than we are. But once again, that star is 40% cooler, so maybe it's fine, right? So it orbits 11 times closer to its host star than Mercury does to the sun. The temperature it has, though, could be, it's still kind of high. It's 490 degrees Fahrenheit. This is for GJ357b, note, okay? So there's 3 planets we've discovered. GJ357d, though, that orbits it. That was the one I started out talking about, actually, to not have people be confused. That orbits at 55 orbits start every 55.7 days, and it's a distance of about 1/5 the distance from Earth's distance to the sun. All right, so by looking at the models, what they found was that liquid water can exist on the surface, and so what we're going to do, obviously, is try to see if there's life there, right? So first thing, okay, gotta figure out what the atmosphere is. All right, so who knows? All right. Last thing is that remember, there's also one other planet, so GJ357c. Maybe one day there'll be more original names for these planets, but right now it seems to be name the star, and then everything after is like A, B, C, D with the star's name in front. And that's how the planets are named. All right. So GJ357c is 3.4 times more massive than Earth. Orbits the star every 9.1 days, so it's still pretty hot, 260 degrees Fahrenheit. So maybe the GJ357d is the only one that may possibly harbor life. Okay, so once again, study was published. Read it up on astronomy and astrophysics, all right? So just look up GJ357. All right, with that, we got to take a short little break. When we come back, I'll let you know why citizen scientists are so important and more about habitable planets.
You're tuned into the all-new Action 1 Network. Turn up your volume.
We can do what we like. So come by. I love it when you come by. I love it when you come by.
But I just took a trip, went and saw the truth. You should get a ride on mamas. I'm the best thing out of Houston since Hakeem, Elijah, Warner, me and Nine.
This is everything. This is where the race. This is my medicine. This is you and me. Everybody jumps in.
He says he loves it when I'm natural. He loves it.
Trying to control the masses, but I'm still skipping the classes, so I don't have to listen to the madness.
So much value in who you are. You should know it's okay to take your time.
Action 1, doing it for the culture.
Get in the action at weareA1.com. Put your money where your community is. Get in the action at weareA1.com.
Man, you still here? Go on and subscribe.
Get into action.
Yo, we back at it again, baby.
What?
Get into action.
3.
Get in the action.
Tell me what is the deal, tell me what is the deal.
So I challenge you today to start strong.
Get in the action.
Tell me what is the deal. Cause I'm calling for you.
Get in the action.
Can you feel that? See, I'm calling for you. Can you feel that? See, I'm calling for you. Can you feel that? See, I'm calling for you. Say how you really.
Action 1, inspiring action.
Look up, because you never know what you will see. Hi, my name is Shen Ge, and I'm the host of SG2 on Space, the only weekly space show here in Houston, with Action 1 Media Group support every Thursday night. So, my goal here is to educate the public in terms of space science, space flight, physics, astronomy, etc. You know, all that cool jazz, and occasionally about aliens as well. So STEAM education, science, technology, engineering, arts, since that's part of the creative aspect, and mathematics is very important to me. And I.
All right, and we're back. You've been listening to SG2 on Space, episode number 40. This is your host, Shen Ge. All right, and hopefully you're watching us on YouTube, SG2 on Space, or at least following me / watching the show on facebook.com/The Shen Show, at Action One Media. We are A1.com. All right. So, today's focus, as I was telling you, if you've been listening, is, wait for it, exoplanets, which are planets outside of our solar system, right? And we talked about hot Jupiters, possible habitable planet GJ357d. Let's talk about something else, more habitable planets. But hey, here's an interesting thing about these telescopes, right? They may have gone out of commission, so to say. Like Kepler ran out of fuel, right? Last year got pretty much, we said, end of life, can't do anything, or we ran out of fuel, so you can't, you know. But all the data is collected is still there. And it turns out that you need more time to process the data than the actual lifetime of your telescope. So scientists are still going over it, and you can contribute as well as a citizen scientist. In fact, this week, there's a possible habitable planet that's discovered by citizen scientists. Now, what are citizen scientists? Citizen scientists are everyday people like you and I, all right? I mean, technically, you could be a scientist and still be a citizen scientist, all right? But everyday people who... So NASA has all these images out, right? From like pretty much all these missions. So you can go in there and you can look at it, and every space mission that NASA does have their own imagery archives. That's many of them accessible by the public, right? For instance, Kepler's. I don't remember the website, but you can access it. So you can look through the images and then examine, hey, it's like, wait a minute, this looks weird, right? What is this? And then you could say, oh my gosh, maybe it's an exoplanet. And then you can contact the NASA scientists, and it'd be like, right, you discovered something that we missed. This is what happened here, okay? So this exoplanet called K2288b, it was discovered by Exoplanets. And why did the original team miss it? Because what happened was that the researchers discounted the record of the first 3 months, because they assumed that the Kepler's not first 3 months, first few days, because they assumed Kepler's measurements were kind of flawed since it was calibrating its instrument or something. Thankfully, it was discovered by citizen scientists, right? And this website, by the way, now that I know what it is, it's called Exoplanet Explorers. So you can look that up, Exoplanet Explorers. So it's a project that allows the public to search through Kepler's K2 observations to locate new transiting planets. Definitely a good hobby to do, help people discover more planets outside of our solar system. So if you have some free time, go there. All right. But anyways, long story short, what is this planet? Okay, this planet K2-288, capital B, the little b. All right. It could either be a rocky world like Earth or a gas-rich planet like Neptune. Okay, so this new world was found 226 light years from Earth in the constellation Taurus. This was according to a statement from NASA, and it's pretty exciting because, one, how it was found, and two, because planets of this size, for some reason, seem fairly uncommon. Gosh, who knows why, right? So the new world, this world lies in a system called K2-288. No surprise. Remember how I told you the nomenclature is, which includes 2 dim, cool M-type stars. So astronomers have this whole thing. Sometimes I wish I have a whiteboard here. One of these days I might bring one. So they have this diagram which essentially shows how the various classification of stars. M stars are red dwarfs, and they're tiny. All right. So, anyways, so these two dwarf stars, M-type stars, are 5.1 billion miles away from each other. All right, that's about 6 times the distance between Saturn and the Sun. So just imagine two stars at that particular distance. That is humongous, right? So that is humongous. But in any case, the brighter star, brighter of the pair, is estimated to be half as large and massive as Earth's sun, while the dimmer companion is about a third the sun's mass and size. All right. So if you look at it, the data suggests that the K2-288 BB, that's funny, BB, planet resides within the host star's habitable zone. All right, which means, once again, planet may have liquid water on the surface. This is how scientists classify if you're in the habitable zone. If you're able to have liquid water on the surface, you're in the habitable zone. All right. So this also may help researchers figure out a phenomenon known as the Fulton gap, which is like there seems to be a scarcity of planets that is about 1.5 to 2 times the size of Earth, and we're not sure why. Who knows? No idea, right? So researchers, after finding out that this planet exists, compare this data to follow-up observations done with NASA's Spitzer Space Telescope, as well as European Space Agency's Gaia mission. Also looked at some ground telescopes data, such as Keck-2, NASA's infrared telescope in Hawaii, to confirm, their findings, right? So we shall no doubt have more discoveries. I mean, more understanding of this planet soon. So hopefully it is a rocky planet within the habitable zone. I mean, we already know it's within the zone, but is it a rocky planet? Hopefully we'll find out. And then if it is, great. Another possible place to have life, right? So it's not just these far away places that may have life. Even close by one, the closest star system, Alpha Centauri, all right, which is, I'm pretty sure, is as soon as we figure out, as soon as we have expanded in our own stellar system, we're one day going to go to a different stellar system, right? And the nearest one is Alpha Centauri. So we're going to go there. And it turns out Alpha Centauri may have habitable planets as well, which is pretty cool. So there's a new instrument. New instrument has been designed to find specifically habitable alien worlds in the Alpha Centauri star system. So this instrument is called NEAR, N-E-A-R, which stands for Near Earth in the Alpha Cen region. So it's a thermal coronagraph installed on the European Southern Observatory's Very Large Telescope, such creative names, in Chile, all right? Yes, and it is a very large telescope, but that's actually what it's called, Very Large Telescope, VLT in Chile. All right, so what are coronagraphs? Coronagraphs block the bright light of stars, so it allows dim orbiting planets to be seen, right? So imagine I have a giant light there, and I'll block part of it, all right, like a giant light. Then you can see what's in the background, right? Makes perfect sense. So, so this instrument is attached to a telescope, on the ground. It's not in space, but there's certain places that are very good for telescopes. Chile is one. There's mountains and there's desert. There's nobody there. It's middle of nowhere. So, so just give you a quick background. Alpha Centauri is a 3-star system. So I mentioned binary star system so far, but Alpha Centauri is a 3-star system, and it lies about 4.37 light years from Earth. So 2 of the 3 stars are pretty much like the sun, same brightness, right? Yellow stars. And together they form a binary star system called Alpha Centauri AB. Then there's a third star called Proxima Centauri, and that's a red dwarf way out there. And Proxima Centauri is actually the closest star to our sun, to our star, 4.2 light years away. All right, so in 2016, astronomers discovered a Earth-sized planet circling Proxima Centauri, the dim star around here. All right, this planet, known as Proxima b, appears to lie in the habitable zone. So they might have liquid water. All right. So, and just this past April, astronomers detected another possible planet circling a little bit further away from Proxima Centauri, this planet known as Proxima c. All right. So, right now, no other planet has been found, but that's why we're going to have this NEAR instrument, right? NEAR. We may discover, I'm thinking we probably would, discover more planets, especially ones that reside around star AB, right? It's been hard to observe planets around AB because star AB, you have two suns. Like, they're really bright. So you kind of, if you have a planet, it's overwhelming light, right? So you can barely detect it. All right. So this coronagraph is a joint project of, and this is interesting, it's a joint project of ESO, European Southern Observatory, and Breakthrough Watch. Breakthrough Watch, that is a program that hunts for potentially Earth-like planets around nearby stars. All right. So, and Breakthrough Watch is interesting because it's a private foundation, organization, nonprofit. It's founded by this billionaire guy, right? It's founded by, in fact, Yuri Melner. All right. So, and it's part of the Breakthrough Initiatives, which is a bunch of programs designed primarily to search for alien life. So good for him. Good that there's funding here. All right. So according to the lead scientist of the Breakthrough Watch, Oliver Guyon, Guyon, he says NEAR is the first and currently only project that could directly image a habitable exoplanet. It marks an important milestone. Fingers crossed. We are hoping a large habitable planet is orbiting Alpha Centauri A or B. I am so looking forward to this. I mean, all the sci-fi movies would be coming true. It'd be like, all right, guys, if we discover a bunch of habitable planets in our closest star system, wow, we should figure out ways to go there, right? That's what I'm thinking. But anyways, yeah. So there's so many places that could have planets that harbor life. One last one I would mention are even really icy planets, okay? So researchers have thought for a while that, quote-unquote snowball planets, which is pretty much iced up, they thought, okay, it may have underwater oceans, maybe it doesn't, right? But there's nothing that could possibly survive on the surface. Well, it turns out that assessment is flawed. So these couple of scientists, in particular, Adiv Paradise, astronomer and physicist at the University of Toronto, they've done simulations to see if these snowball planets could have habitable places on land. And it turns out, yes. All right. So they did thousands of simulations modeling climates of theoretical snowball planets on a huge variety of continent configurations. All right. And what they found is that some of it may actually have, parts of around the equator may be habitable. In some temperatures could be above 50 degrees Fahrenheit, which sounds, still pretty cold, but not deathly cold. 10 degrees Celsius, right? So that's pretty cool. Let's see what happens. I'm sure we will, their models. Let's see if we can confirm that with reality. I suppose there's a bunch of planets like that in our own solar system. There's some probably out there, for sure out there. So we shall see. Look for this new study on the July 18th issue of the Journal of Geophysical Research, planets. So with that, I am done. I am kidding. All right. I'm kidding because I want to talk about some UFO stuff, because that's really actually all I really want to talk about. and it takes forever to get to this point where I actually want to talk about it. So there's a new show on Netflix, which you may have heard of. I may have mentioned Bob Lazar, Lazar, in the past, and he says he worked at Area 51, and he tried to blab a lot of secrets since government has reverse engineered alien technology, blah blah blah. Government obviously says no, we didn't. And if you look on his Wikipedia entry, there's some controversy, but who knows? Maybe he's telling the truth. So this Netflix series, let's watch a preview, and it will tell you. Maybe I think you should watch it.
Nothing good comes from the UFO field for him. This is a reluctant UFO messiah. It changed his life.
This week we've heard the contention of UFO researchers that there's a secret government within our government.
Well, there's several, actually 9 flying saucers, flying discs that are out there of extraterrestrial origin.
The live interview with the shadowy dentist drew international attention. Portions were broadcast by radio in 6 European countries and in a nationally televised TV special in Japan. Despite numerous inquiries and feelers, Dennis has remained anonymous until now. His real name is Robert Lazar. He says he was hired to work at an area called S4, which is a few miles south of Groom Lake. At S4, he says, are flying saucers, antimatter reactors, and other working examples of technology that is seemingly beyond human capabilities.
I did not believe that this should be a security matter. Some of it, sure. But just the concept that there's definite proof. We even have articles from another world, another system. You just can't not tell everyone.
It was like a Twilight Zone episode. It just kept getting stranger. The fact that was happening at all was the weirdest part. Look, it's been 30 years, and all of a sudden you raised it to this level? You know, this is a powerful technology, fearsome technology, and you just don't want everyone to have it. It'll become obvious how to make constructive as well as destructive devices from it. It's my only guess as to why they have never released information. It's kind of difficult. Once you release the technology to be analyzed and give it to everyone, they can just run with it. You really can't keep the weapon potential hidden. You really can't. Look, with ET technology, you can literally rule the world.
Well, I am telling the truth. I've tried to prove that. What's going on up there could be the most important event in history. You're talking about contact, physical contact and proof from another system, another planet, another intelligence. That's got to be the biggest event in history, period.
And it's real.
And it's real and it's there.
Yeah, besides the 1980s Atari-like music, I think that's something to be really looked into if, you know. So, I will say, you know, that this supposedly there is some controversy surrounding the guy. One thing is this kind of worries me a bit. He says he went to MIT and I think Stanford, but anyway, got really advanced degrees, right? And then the schools refuse. They say your name is never here. You never went here. You never graduated. But he was working in Los Alamos, you know, the national lab. So how did he get hired without any degrees? It doesn't make any sense. And there's proof that he worked there. So, government conspiracy at the highest level, force universities to expunge his educational records. Who knows? To discredit him, right? So there is that possibility. I mean, if there is a government within government, then technically they have more power than the current government that we know of, since they don't need to follow any laws, really. Anyways, Wow. So that goes really into the conspiracy world, which I could talk quite a bit about, but let's not. But point is, go watch this Netflix show and decide for yourself, right? It's called Bob Lazar, Area 51, and Flying Saucers. You can find it on Netflix. All right. One other thing I would like to mention before everything concludes is that I had an interesting conversation about Marfa lights today. All right. I don't know if people know what they are, but I kind of want to take a trip out there, and I'll let you guys know when I do because it should be interesting. So Marfa is a tiny little town, West Texas, and is not really, like, it's not like a place you would go to have a vacation. All right. So these what's known as Marfa lights were Marfa ghost lights, and they observed near U.S. Route 67 on Mitchell Flat, east of Marfa, Texas. And they're pretty much unknown what they are. They're colored lights that just suddenly disappear, dart across the sky, and they can remain stationary. You can pulse on and off. Sometimes they become blindingly brilliant. Other times they're super dim. And nobody has quite figured out what they are. Some of the dumb reasons, in my view, is believing they're car lights, which is really dumb because these lights existed before cars were even made, like early 19th century or 20th century. Yeah, so no, it's not that. All right. But so I don't know, atmospheric phenomenon, I highly doubt it. What I think, as always, when I can't explain things flying in the sky, you guys probably already know what I think. So I guess I will have to say it. Yes, it's some kind of UFO, right? Except it's not the typical one. I don't know what it would be. Who knows? Or it could be ghosts, as some of the natives believe. Native Americans, they used to think it was, they thought it was that. So maybe some people. Who knows? I don't know. But if you ever go there, definitely look up. But remember, even if you're not in Marfa, I leave you with this thought. Look up. All right? Because you never know what you will see. With that, all right. So that concludes SG2 on Space. Follow me on Facebook.com/The Shen Show. Put your YouTube playlist, add it to whatever YouTube you have. Follow me, SG2 on Space on YouTube. And one last thing, of course, I was going to say that I am going to do the Apollo 13 escape the room thing at Escape Hunt Experience Houston at 9:30 p.m. Wow, that's really specific. August 3rd, 2019, Saturday. So feel free to join me or not. So anyways, with that, look up because you never know what you will see. Thank you, everybody.
Action 1, inspiring action.
Look up because you never know what you will see. Hi, my name is Shen Ge, and I'm the host of SG2 on Space, the only weekly space show here in Houston, with Action 1 Media Group support every Thursday night. So, my goal here is to educate the public in terms of space science, space flight, physics, astronomy, etc. All that cool jazz, and occasionally about aliens as well. So STEAM education, science, technology, engineering, arts, since that's part of the creative aspect, and mathematics is very important to me, and I feel like Action 1 Media's goal is aligned with mine. So together we hope to encourage the knowledge and especially the passion and interest in outer space in our Houston community. Tune in to SG2 on Space on Thursdays at 8 p.m. U.S. Central Time. Look up because you never know what you will see.
Peace, brother Atum Ra, and you tuned in to Action 1 Network.